Hello, ladies and gentlemen. Here is the review sheet for our trig unit. Now, the one thing I need you to do is make sure that you have all your lessons 1 to 11 with you when you work on this trig review, and then especially when you begin your test, which starts on Friday and goes through Sunday. Please make sure that you look up every question before you do it. You can take your time. It doesn't all have to be done like instantly. Give yourself your best shot at success. All right, so which of the following angles when drawn in standard position would be coterminal with an angle that is 818 degrees? All right, so guys, this is lesson 1. If I draw myself a nice big set of axes, here's my 0 degrees, my 90, my 180, my 270, and my 360. Back to 360 would be a full rotation. So I look at the angle and it's 818 degrees. So if I start at 0, here's a full 360 rotation. So now I have to do another full 360 degree rotation. That brings me up to 720 degrees. Now I need another 98 degrees to terminate here in quadrant 2. So this 818 is coterminal with the 98 degrees that terminated in quadrant 2. Let's look at number 4. I'm going to do the even and you're going to do the odd then. An angle that measures 5 radians in degrees. All right, so if I am 5 radians and I want to go back to degrees, I am going to multiply by pi, 180 over pi rather. So I multiply by 180 over pi. So I'm going to need my calculator for this. So any calculator will do on these now. Let me just find my calculator on this busy screen that I have. All right, here it is. All right, back to here and here. All right, so now what I'm going to do is have 5 times 180, get an answer 900, but now I have to divide that by pi. And there I am roughly 286 degrees, number 3. So we get to number 6 now. A circle whose diameter is 4 inches, so here's a circle. My diameter is 4 inches, which makes my radius 2 inches. So I'm only going to label the radius. And has a central angle, so here's my central angle, which is pi, and I know I'm the worst artist in town with this mouse, but you know, here's my angle, pi over 8 radians. Which of the following gives the arc length? Remember, this was now in lesson 2. Oh my goodness, we are really going back to the beginning. Arc length, S, and in the video I said, think about this as S theta R. I usually say yes they are in class, so S theta R. So this is now my theta, pi over 8, multiplied by my radius of 2 inches. So this gives me pi over 4 when I reduce. So pi over 4 inches would be my arc length. Always, you know, and like I say to you, do the problem as if it's brand new, and then look at the choices to see, you know, how you should have your form. So this one wanted it to stay in pi form. If it was in terms of like actual inches on a ruler, you would have taken 3.14 and divided it by 4, and then that would have given you, you know, a measure you can get on a regular ruler. Now, which coordinate pair would not lie on the unit circle? If you are not on the unit circle, you would not fit in the Pythagorean theorem, because remember, when you're on the unit circle, I just am going to type this one now. if you're on the unit circle, your point, every point would be cosine of theta, sine of theta. So for my angle, so here's theta, cosine theta, 4x, and sine theta, 4y. And that's never going to change. So this was a pretty big deal when it came to the unit circle and so many things. So from this, the Pythagorean theorem then says that if you have cosine squared, so now just bear with me because it takes so long to type, but I can't write all this. It would just be too difficult. Cosine squared theta so here is where my theta should be. All right, cosine squared theta all right, so maybe I should just go back to the pen. Cosine squared theta plus sine squared theta equals 1. That means what I need to do is take each one of these and square the x, and then square the y, add them up, and see if they equal 1. Now, if they equal 1, they lie on the unit circle. If they don't equal 1, they don't lie on the unit circle. So let's start with number 1, or choice 1, and I'll go real slow right next to the choice. Now, the cosine would be -3/5. So if I use my calculator, and you know with fractions you have to use parentheses. So I have -3 divided by 5, close that and square it, plus now the sine squared or the y squared. This would be parentheses 4 divided by 5, close it, square it, hit enter. It equals 1. This is definitely on the unit circle. So now let's do number 2. We need 40 divided by 41 squared plus negative, don't forget the negatives, 9 divided by 41 squared. That equals 1. So number 2 is on the unit circle. So moving along, let's try number 3. 7 divided by 25 squared plus 24 divided by 25 squared is 1. So clearly it's choice 4. I mean, there's really no other option, but let's just show why it's number 4. This would be 11 divided by 27 squared plus 26 divided by 27 squared. And that is not 1. So which one is not on the unit circle? Absolutely choice 4. So remember, when you are on the unit circle, your x-coordinate is equal to your cosine. And if you have to label a picture, you need your cosine, which is adjacent over hypotenuse, or sine opposite over hypotenuse. Now 10, when drawn in standard position, it is known that A is less than 0. Now this brings us back to everybody's positive in quadrant 1, students, sine and cosecant positive in quadrant 2, take, and this is tangent and cotangent, calculus, cosine and secant. So this is how we remember our positives, negatives in the quadrants. If sine is negative then that means I am not in quadrant 2 and I am not in quadrant 1, because this is where all my signs are going to be positive. Sine is negative. Cosine is positive. That means, check, I am in quadrant 4. So you want to get this right each and every time you draw out your quadrants, you will be in business. Now let's take a look at number 12. An angle is drawn in standard position. All right, so now we are on a graph. And if I am in standard position and my x is positive and my y is negative, that means I came out to 12 on the x-axis, positive 12, and I went down to negative 5 on the y-axis. And let me just, even though this is just work, to get to the answer, I'm going to label so it makes sense to me. This is now my point at 12, negative 5, and this point is in quadrant 4, which is very significant. A lot of you are having trouble with this. This is lesson 3, and we did 3 days with this in lesson 3, and then we used it again in lessons 4 and lessons 5 and lesson 6. So we did 6 days with this particular topic, and it was on 2 of your quizzes. So please do not discount this or just try to forget about it. So here would be the angle that we draw. So here's my angle drawn in standard position. Now, which of the following represents this angle? Now, this is when you were saying, okay, now if I think about this in terms of a triangle, this had a base of 12, and it had a height of 5. And I'm in quadrant 4. And if I'm in quadrant 4, I am going to be positive for cosine. That's a super big thing. Remember, all students take calculus, cosine. So right now, this guy is off the table and this guy is off the table because cosine's positive. Now, the next thing is I need to know what the hypotenuse is because I don't have the hypotenuse. I'm just going to call it h. So now I'm going to pull up my calculator and say Pythagorean Theorem, altitude squared, 5 squared. And again, you're on a triangle. We only have positive values on the triangles. The signs, positive sign, negative sign, is the quadrant. It's the location in trigonometry. So 5 squared plus 12 squared equals 169. And now the hypotenuse would be the square root of 169. And that would be 13. So now I know my hypotenuse is 13. So what would represent the cosine? Adjacent to the hypotenuse. And that would be choice 2. I hope I, explained that clearly for you guys. I hope you followed it. It was a real big deal on all our past problems. As is this one. This is another triangle. And in this triangle that they're giving me, it's sine, which means this is the opposite side and this is the hypotenuse. So now, and I am between 90 and 180, which is telling me I am in quadrant 2. So I'm just going to draw quadrant 2 because it's so hard with this mouse. So my y is positive and my x is negative in quadrant 2. This is sine. Sine is saying that I have a height of radical 5. I went up radical 5 units. My hypotenuse is 3. What is the base of this triangle? Well, Pythagorean Theorem, altitude squared plus the base squared is equal to the hypotenuse squared. Now, rad 5 squared is 5. And the base, we're looking for it. And 3 squared is 9. So if I subtract 5 from 9, I get 4, and the base will now be the square root of 4, which is 2. So the base of this triangle is now 2. It's heading in the negative direction. So if I want cosine, I am going to be negative. I went 2 in the negative direction, and my hypotenuse is 3. Whenever you have these types of problems, you absolutely must go back to the Pythagorean theorem. This ended on 15. Where is problem 16? Well, I don't know what happened to 16, so I guess you're not getting 16. All right. Which of the following represents the period of this problem? Now, this is when we were dealing with lesson 9. We started it talking about it in lesson 8, and then we went to lesson 9. Period, by a formula, period equals 2 pi divided by the frequency. Here's the frequency. Here's my B. So this would be 2 pi divided by 2. And the 2's would cancel, and that would give me pi choice 1. Number 24, when graphed, a sinusoidal, again, that either means sine or cosine, completes 8 full rotations from 0 to 2 pi. So this guy is moving fast. This guy, if it completes 8 full rotations, this guy has a frequency of 8. This is the B. Like, so that means it's got a big frequency. It's like going up and down very quickly. So what would be the period? Well, 2 period again, same formula, 2 pi divided by 8. And this would reduce to 1 over 4. So in pi over 4, you would have a full rotation. So that would be 45 degrees. So instead of taking 360 degrees for a full rotation, you have full rotation of 45 degrees. That's pretty fast. All right, number 26. A particular chemical reaction has a temperature given by this sign formula, where M represents the number of minutes since the reaction began. Okay, so instead of X, we're using M for minutes, and we did this in lesson 11, our real life trig functions. Which of the following gives the period? Well, okay, so again, here's my frequency, my pi over 9. So my period is now 2 pi divided by pi over 9. So you either have to be really, really savvy on the calculator, or you need to say, all right, if I'm dividing 2 pi, and I'll use the old-fashioned division, divided by pi over 9, division of fractions, the first one doesn't change. So we definitely call upon all our old work. The division becomes multiplication, so a nice big multiplication dot. Reciprocal, 9 over pi. The pi's cancel on the diagonal. 2 times 9 gives me 18. So this would be, the period would be 18 minutes. It takes 18 minutes for this chain reaction to complete one full cycle. 28. For an angle, it is shown that both its cotangent and sine values are negative. If cotangent is negative, that means tangent is negative. And if sine is negative, its cosecant is negative. So if I go back, and this is, going back to lesson 3, all students take calculus. I can't be here because everybody's positive. And sine is negative, so I can't be here. Cotangent is negative. I can't be here. So that means I have to be a quadrant 4 angle. Quadrant 4 is going from 270 to 360. So which angle can I be? 322. You know, take your time, because hopefully now that we've spent all these weeks, you are now going to feel a lot more comfortable with these problems. I should have taken this one out. This is secant is the reciprocal, so you would have had to take all your cosines and flip them over. But I didn't do that with you guys on distance learning. If we were in the classroom, I would have, but I think this would have just been far too difficult. So I'm just going to say get rid of that. Let's now go. Oh, here's 16. I got to fix. I'll fix these pages. All right, so 16. F of x is x over 2 and g of x is sine of x. Composition. F of 90. Well, 90 divided by 2 gives me 45 degrees. So this now wants the sine of 45 degrees. So one more time. F is 90. You put 90 into F. 90 divided by 2, 45. So now you're putting the 45 into G. So sine of 45, this is going back to my special. We're back at less than 3 again. 3, 4, and 5. 1, 1, rad 2. So sine of 45 would be 1 over rad 2. And then you rationalize by multiplying by rad 2 over rad 2. And you get choice 1. Or you could just go back and you can look at the charts because we wrote out all the things and some of you have them memorized. Which of the following cannot be the sine? Well, remember, sine and cosine both have to equal 0 point something. So the minute you are 1 point something, you can't be sine. So there you go. Didn't even have to do any work. I just had to remember that definition, that sine is a value between 0 and 1. Number 20, a sinusoidal equation in the form of this, which is all we've been doing since we started this, has a maximum of 14 and a minimum of 6. That they just gave me the range. So if they gave me the range, and that is -6 to 14. And they want to know the value of C, which is the midline. The range comes, the midline is going to come from half the distance. So if I think about my low of 16 to my high of 14, that's a span of 20 steps on a graph. And if I divide that in half, those 20 steps divided in half gives me an A of 10. So that gives me an amplitude of, that gives me an amplitude of 10. Now, from 10, wait a second, I think I went a little too fast in my brain. I went up 4, it gives me 20, yeah. So that gives me an amplitude of 10, I'm sorry. So if I were writing this equation out and I said, okay, here I go, I have y, wow, that's sloppy, equals 10 sine of x. What did I do to 10 if what did I do to the sine if I oscillate up 10 to hit 14, and then from that midline I go down 10 to hit -6? That means I had to have a midline at 4, because that's how I get my range. oscillating up 10, positive 10 plus the midline is 14, and going down 10, 4 minus 10 lands me at negative 6. So my midline is at 4. Sorry that I got a little tongue-tied there for a second. Okay, so the pages were out of order. That, again, I apologize for. I don't know how that happened, but let's just move on from here. Now we're on 32. Determine two different angles, one negative and one positive, that are coterminal with 210. All right, let's go back. This is lesson 1. These are the nice problems. Let's have our 0 degrees, our 90 degrees, our 180, and our 270, and then we're back to 360. Now, if I want to be coterminal with 210, here's my 210 degrees. So, one negative would mean I started 0 and I went backwards. I went negative to land at 210. So that would mean 360 minus 210. If I went negative 150, I landed at 210. Again, a full rotation is 360. And if I subtract 150, I'm coterminal with 210. So there's my negative answer, negative 150. So that's my red. Now let's do a positive. Well, a positive rotation would mean I need to loop around at least once to 360 and then go to 210. So now for my positive, I need to have 360 plus 210. And that gives me 570. So my green positive rotation would be 570. So coterminal, lesson 1. 34, range. Okay, whoops. The range on 34, this is just like the problem we did a moment ago. If I'm going to get the range, here's my amplitude, here's my A. I am oscillating up and down 3 from my midline, which they're calling C in the other problem, so I'll call it C, of 8. So this means my range is going to be negative 3 plus 8. And from 8, I went to positive 3 above the 8. And showing your calculations means just this, guys. Look at how I'm showing you exactly what my thoughts are. This would be going from 5 to 11. So the range on this would be 5 to 11, the amplitude and the midline together. Okay, 36. We are back to, come on, board. All right, we're back to making a triangle. Now, this triangle, they're letting me know I'm in quadrant 3. This is quadrant 3. And again, so this is lessons 3 through 6. Here's my negative x. Here's my y. I am bigger than 180, smaller than 270. And my sine, so they're calling it angle B. I like theta, but they're calling it B. Negative rad 21. Now, the rad 21 is not negative. It is the direction that is negative because it went down in towards the negative y. The hypotenuse, cosine, is opposite to the hypotenuse. The sine is, the hypotenuse is 5. So now Pythagorean theorem. I need the altitude squared plus the base squared to equal the hypotenuse squared. Now 5 squared is 25. And rad 21 squared is 21. So I'm going to subtract the 21 from the 25. And my base squared is going to be 4. But if my base squared is going to be 4 and I want the base, I have to take the square root, and that's going to give me a base of 2. Now this 2 headed in the negative direction. It's also going in the negative direction. So if I wanted the cosine, I want adjacent to the hypotenuse, I headed -2 to the hypotenuse of 5. And I didn't have to worry about radical form because in this instance, unless I made a mistake somewhere, rad 21 squared is 21, 25. Nope, no mistake. There's no radical for this answer. All right, 38. Determine the period in simplest form. Again, the period is the frequency. You need the frequency, 2 pi divided by the frequency, which is 4 pi over 5. So again, this one, you have to be really, really good on your calculator for this. I'm going to write it out, 2 pi over 1. Now division, this is the division. When I divide fractions, remember, I turn it to multiplication, and then I take the reciprocal of the bottom, so that's going to be 5 over 4 pi. And if I reduce, the pi's are going to go away, and 2 is going to go into 4 twice, and this is going to give me a period of 5 halves, or 2.5. So in the real world, I don't know, maybe it was hours. This would be 2.5 hours. Or if it was one of our other problems which had months, this would be 2.5 months. Whatever. For this sine curve, the period is 2.5 or 5 halves. Number 40, find the exact value. Now, when you're doing exact, you have to, again, go to your special triangles because we are not allowed to use decimals. You can't just type into your calculator and say, oh, that's what I'm going to do. So if this is a 45-degree angle, this is our, let me just label this as best as I can. This is our 1, 1, rad 2. Or you can look at the chart. Remember, secant is the reciprocal, and I'm going to use it. So secant is the reciprocal of, of cosine. So let's start with this, and let's say the cosine of this angle, and I'll write that in, is equal to adjacent 1 divided by the hypotenuse, which is rad 2. Now, I'm not going to rationalize this right now, because if the cosine of theta, there's my little theta, or my 45 is 1 over rad 2, the secant now flips this over. So now this gives me the secant of the angle, which is 45 degrees, is rad 2 over 1. So this guy, the exact answer is just rad 2. So please take your time and, you know, draw out the triangles. Again, use your notes. You know, you might have to do a little searching, but you can find everything that you need. All right. Now, 42. The graph below, I'm definitely giving you this. Now here, look it. Here's your max, and here's your min. This is a span of 12. 15 minus 3. is a span of 12. So your range equals 3 to 15. And the midline, the center of this, is going to come from 15 minus 3, which equals 12, divided by 2 equals 6. I'm sorry, going a little too fast. That's what I did get before when I got myself all tongue-tied. This is my amplitude. So my amplitude is 6. What that means, and now let me just draw it out as neatly as I can for you. All right, here's my midline. Here's my 0. My zeros normally are here on a basic, but now it was pushed up. And because it was pushed up from this line, if I go up 6, I hit 15, and if I go down 6, I hit 15. So that means my amplitude A is 6. Sorry that I got tongue-tied at the beginning. Now, if I'm going up and down 6, what number that if I add it to 6, I get to 15, and if I subtract 6 from it, I get to 3. Well, that is when I now do, the midline. And the midline is now equal to the 15 plus the 3, because I'm looking to see, where the middle of this is. So now this is an average. The midline is an average, which this equals 18. And then I divide that by 2, I get 9. My midline is 9. So this here gives me y equals 9. So now if I were going to write this whole thing out, this would now give me the equation y is equal to the amplitude 6, and it's positive 6 because from the 0 degrees, remember the y-axis is 0 degrees for x, you went up first, and that means it's a positive 6. If you went down first, it would have been a negative 6 again because of direction. So y equals the sine of, and they didn't give us any label, so I'm just going to call this x. I'm going to, assume this is 360 because this, to me, if there's no label and they give me one full rotation going positive and one full rotation going negative, I'm going to assume I have a 1B, and then I have my plus my midline, which is 9. So again, since there's nothing here at all labeled, I am going to call this 360 for one full rotation, and I'm going to call this negative 360 for a full rotation. All right, so here they want us to graph, and I'm only going to graph the sine. I am not graphing cosecant. Again, that was one of the things I took out of our distance learning. Sine, my amplitude, and this is what I'm saying to a lot of you. You guys have to label. If you don't label, you're going to lose half the credit on the problem. That would be a shame. My amplitude is 1. It's positive, so that means I'm going to go up first. My frequency, my B value is 1. And my period is 2 pi divided by my frequency. Wow, that's sloppy. Sorry about that. That's 2 pi. And my midline, there is none. So my labels are set. Now my x is labeled perfectly. My y has to be labeled. If I only have an amplitude of 1, here are my labels on y. So sine starts at 0. And at 90 degrees, I hit 1, according to the unit circle. At 180, I'm at 0. At 270, I'm at -1. And then I am at 1. If I rotate clockwise, I hit -90 first, then I hit 0, then I hit -270, then I hit, and here is my graph. And guys, even with the mouse, notice I'm making curves. Please, some of you are still giving me peaks. You're giving me sharp absolute value peaks. You can't do that. You got to curve it. So use your pencil and make sure there are curves. So now we have a question, just like the ones on the packet, you know, how many times are they going to cross each other? You would have to, again, for each one, amplitude, frequency, midline, range. Amplitude, frequency, midline, range. Label, and then graph, and tell me how many times they cross. This guy here, they gave you a triangle. Sine, opposite over hypotenuse, 4/5. I'm actually going to type these. This would be 4/5. Cosine, adjacent to the hypotenuse, adjacent, 3/5. Tangent, opposite over adjacent, 4/3. Now secant is the reciprocal of cosine, 5/3. Cosecant is the reciprocal of sine, 5/4. Cotangent, reciprocal of tangent, 3/5. So you know one, you know them all. You heard me say that many, many times on all of our papers. Anything else? Okay. And that's it. So I just went through all the odd. I know this was a pretty long video. I'm going to need you to do the evens, and then please show me your work, and then I'm going to post all the answers before you start the test. Go through everything, and again, when you start the test tomorrow, make sure you have all, this will be 12 lessons. The review is lesson 12. Make sure you have everything with you so that you have your best shot at success, because that's really what this is all about. We want you to learn, and whatever you move on to in the years that follow, we want you to be successful because you have the background knowledge you need. Good luck.